Today's personal computer users employ their PCs as repositories and access points for ever-increasing volumes of digital information. The most prevalent model for search today, driven by the popularity of general-purpose web search, consists primarily of presenting a text list of results in response to a text-based keyword query. But in a more personal data store, this simple model falls short in conveying understanding of the corpus and often fails to guide users to their search destinations when the desired search criteria is not expressible purely in keywords. To address this need, we've developed Facetmap, a novel graphical visualization for searching and browsing using the concept of faceted metadata that is designed to scale gracefully in several ways: in the size of the dataset, in the variety of the dataset items and attributes, and in the size of the display. Facetmap is currently implemented as a visualization for the My Life Bits research project, a personal lifetime store of digital information in a database. But because Facetmap uses dynamically generated, standard structured query language statements as an interface, it is designed to adapt to a wide range of SQL-based stores. Facets, shown in the interface as rounded rectangles, contain different groupings of item attributes or metadata that represent useful ways of narrowing down a large dataset, for example, by type or by date. When a particular facet value is selected, the selected facet moves to the right, and the data is filtered to items matching the selected value. With the remaining unselected facets on the left, the screen is reorganized to show facets and facet values that can be used to further filter the remaining dataset items. When the dataset is sufficiently narrowed, thumbnails of the individual items begin to appear. Hovering on the thumbnails offers a more detailed pop-up preview of the item. When interacting with Facetmap, each selection adds another clause to the dynamic query. By selecting Pictures, for example, we are made aware of what locations the pictures were taken in. We then narrow down to Washington State. We minimize the type facet to devote more space to the location facet, and select Bellevue from among the 4 cities. Finally, we notice that these pictures were all taken in July of last year, and we choose July 23rd as the date. Selecting various metadata values from different facets builds what amounts to a complex query over the dataset items. Here, with only 5 clicks, we've narrowed down a dataset of 46,000 items down to just the 15 representing pictures taken on July 23rd in Bellevue, Washington. Query clauses can be eliminated or relaxed at any time with similar direct manipulation. Of course, full-text keyword search is also always available and is integrated into the visualization as another facet. As the user interacts with the dataset, Facetmap displays the current distribution of items in multiple ways simultaneously by showing the best choices for narrowing the dataset down further. For example, when the dataset is narrowed to music items, facets unrelated to music disappear and the remaining facets expand to fill the space. Facetmap does this automatically with a recursive space-filling algorithm based on a modified tree map which causes groupings with more items to be given more screen space and groupings with no items to disappear completely. This algorithm allows Facetmap to scale to many different sizes of display, automatically exploiting the available screen space. Understanding, exploring, and searching large data stores effectively is a task of increasing importance in the personal and professional lives of many PC users. We have developed Facetmap, an interactive, data-driven visualization to explore searching and browsing large faceted datasets in a scalable way.